Hello everyone, this is Rahul Shrestha here to present you the fifth part of the measurement chapter for class 8. So we are almost at the end of our chapter, and today we will be studying about two of the fundamental quantities, which are length and mass. So starting off with length, as you already know, is the distance between any two points and can be measured by using tools like ruler, measuring tape or a meter rod, using the standard units such as feet, meter, inches, kilometer, etc. Now, out of all these units, meter has been selected as the standard unit in SI system for measuring lengths. So what actually is a meter? Or precisely speaking, how much of a length is a meter? If you remember, while discussing about the standard units in the third part of our chapter, I explained how all the different units of length were developed. Basically, the people in the ancient times took some set amount of length and defined them as the standard units. And that is how units like cubit, foot, and meter were developed. And later, they made exact copies and replicas of this standard lengths and distributed them to all the different countries of the world to standardize these units, which made all the measuring units to be of a constant size all throughout this world. In order to create meter, the scientists at that time took the distance between the equator and North Pole passing through Paris and divided it by 10 million. And this fraction of length, which is the 1/1,000,000th of this distance, was taken as 1 meter. Then they took a platinum rod of this same length and kept it at the Bureau of Weights and Measures in France and named it as the meter of the Archives, whose replicas we still use all around the world for measuring length. Now, do understand that the definition of meter has changed throughout our history. According to the definition which is given in your books, which was defined at around the year 1799 AD, a meter of length is nothing but the length between two fine gold lines present on a platinum iridium rod at 0 degrees Celsius, which is kept at the International Bureau of Weights and Measures. The temperature here, which is 0 degrees Celsius, is very important to be maintained, as we know that with the change in temperature, the size of the metal, like platinum in this case, will change too, which must not happen, at least with one standard unit on the basis of which the whole world is going to perform its various measuring activities. Ani त्यस्तै यो platinum iridium alloy also plays a very important role your rod बनाउनमा, because this alloy does not degrade much with time, जस्तो कि एउटा iron rod degrade हुन्छ because of rusting. But even after that, this is what has actually happened. Over the duration of more than 200 years since the rod has been safely kept at the bureau, it has actually degraded and reduced in size a little. But this reduction is in a very small amount, like almost 1/1000th of the original size. And this change would not affect our normal day-to-day activities much, such as buying and selling goods. So this definition of the meter is good enough for our day-to-day task, but is definitely not perfect for science or scientific researches where we need precise measurement of the quantities. So the Bureau tried to define this again once in 1960 by using the wavelength of light emitted by Krypton 86, and then most recently in the 1983 by using the speed of light in vacuum, which says that 1 meter is the distance traveled by light in 1,299,792,448th of a second. Of course, this number is quite big, and it is so because it is the distance the light travels in 1 second. But for now, you don't need to remember this. The definition in your book is enough for a class 8 student. So as we know now that how much is 1 meter, we can measure all the different length and distances of stuff by using the multiples and submultiples of meter. For the things whose size are smaller, we use the submultiples, which are the smaller units of meter. And for the lengths which are very large, we use the multiples, which are the larger units of meter. And we also have some even larger units like light year and parsec, used to measure the distances between celestial bodies, which you will be studying in your senior classes. Now let's talk about mass. Mass literally is the total amount of matter contained in a body. As we already know, every single object is basically made up of matter, and matter is anything that occupies space or simply has atoms and molecules. अनि हजुरहरूले पहिला पढ्नुभएको होला कि every atom or molecule has some mass, which is atomic mass or molecular mass. So the totality of the masses of all the atoms in a body is basically the mass of that particular object. We measure mass of a body by using a beam balance and by using units such as kg, pound, gram and quintal, etc. Out of which kilogram has been taken as the standard unit for measuring mass in the SI system. And just like in the case of a meter, a platinum iridium cylinder termed as Lagrange K of 1 kilogram mass has been kept at the International Bureau as a standard unit, which makes the definition of 1 kg mass as the mass of this platinum iridium cylinder at 0 degrees Celsius kept at the International Bureau of Weights and Measures in Paris, France. And all the things that I said earlier about the platinum iridium alloy and temperature applies here as well, which means that this cylinder has also degraded with time, and the scientists are again trying to find a new definition of this 1 kilogram mass, and I think they are soon enough going to find one. As per the reports, the scientists are using this perfectly round sphere made up of silicon to give us the new definition of kilogram. Now, just like meter, kilogram also has its own multiples and submultiples to measure the masses of different sizes. Now, there is one more topic that we need to discuss here, which is weight. A lot of times, इस्तो normally कुरा गर्ने बेला हामीले weight र mass लाई almost same मानिहाल्छौं, but it is not so in reality. Please try and understand कि mass is an inherent property of an object जुन कहिले पनि change हुन्न, at least until a chemical change takes place. Here, inherent means something which cannot be separated. So mass of an object cannot be separated from that object, no matter the place or condition. But weight, on the other hand, is not an inherent property, which means that it changes depending upon the place and condition. Do you know there are places where our weight will be zero? Like in space or at the center of the earth, everything will have a weight of zero magnitude. And the reason behind this is that weight is a vector quantity which is a product of mass and acceleration due to gravity. And as we already know that in space, at a distance very far from the earth and at the center of earth, gravity is zero. So the weight of the object will be zero as well, as anything multiplied by zero is zero itself. Now, if we look at the definition of weight, it is the force with which earth pulls anything towards its center. And this pulling of the earth, as we already know, is due to the earth's gravitational pull. And this is why the weight of any body is measured by finding the product of its mass and the acceleration due to gravity that is in effect at that particular body. We will read in detail about gravitation and weights in class 10, and if you are still curious, you can check out Mr. Rajkumar Gurung sir video on Bhairava TV's channel for getting an in-depth understanding on these topics. But for now, let's check out some more differences between mass and weight. So the SI unit of mass is kg, which we have already read. If you see the definition of weight, we just learned that it is a force. Now because weight is a force, so definitely its SI unit should be Newton. Then again, mass of a body can never be zero, while weight can be zero, as we discussed earlier that in space and at the center of the earth weight is zero. Mass of a body is same all around this universe, as it is an inherent property of a body, while its weight varies from place to place due to the change in the gravity. And the last difference is that mass is measured using a beam balance, while weight of a body is measured using a spring balance. Now, after reading all about mass and weight, can you people tell me that when we are weighing ourselves, are we measuring mass or weight? We'll discuss this in our next session. Until then, take care and be safe. Thank you.